here. Those of us that are not here, go to my website after this, and you can get the key posted, and you can look at this later. Okay.
Oh, I got them right there.
So.
86.
This is the correct. These are the correct questions or answers to your multiple choice section, but disregard 42 through 45 because they're just not part of the. They're not part of it. I forgot to give you all this, so. Okay, is everybody almost done?
Yeah, I'm done.
Okay. Please count up the number missed. Count up the number missed, and let's write it on the front of the entire packet. Wherever the front is, write the number missed on the top of the front of the packet. That way I can get it. I can just, record it. Now, as far as the grades go, how's it going to affect your grade? They're all going to be curved. So let's not get upset if you didn't do as well as you wanted to. Okay.
That's yours? I didn't get it all. Oh, I missed all of them. Oh,
All right. All right, has everybody got this graded? Good and graded? Let me know if I need to slow down. Okay. Now, for 2 reasons, I want you to focus completely on grading the FRQs now. And, wait, you're still working home? Let's go ahead and just put these away. Put the multiple choice away. Y'all can have time. We'll have time for y'all to look at those, and we'll work problems out that you missed and answer questions about that, towards the end of class. So put this away. Let's focus on the FRQs, please. Okay. All right, y'all ready? Okay. Yeah, we're gonna do FRQs. So I'm gonna be doing this 2 ways. I'm going to show you some of it's calculator stuff, so I can't show you much. Maybe like pictures, diagrams. Some of it's kind of just stuff that the answer is like either you know the answer or you don't. So I won't be giving you that worked out. Okay. But some of the problems I worked out for you. So I'm going to show you the answers. We're going to grade them. Then I'm going to show you the work, if there's work. Some of it is either you know it or you don't. All right, so here's number 1. Let's focus on the first section, letter A. Okay? So letter A, just grade letter A. It's worth 3 points. So, guys, you get a point if you wrote from 1 to 10. Those are the limits. If you did not, guys, if you did not write from 1 to 10 on your lazy S, you don't get that point.
1 to 10? Okay.
You have to, that's what, I've taught the whole year. I've said, you must be tasteful. Like, don't throw sloppy information, incomplete information at me. That's what I meant the whole time. You have to be tasteful as you work. Because if you just put the answer as 18, well, that's just 1 out of the 3 points, isn't it? Now the integrand. What's the integrand? It's the inside. So if you've got the integral of the square root of x minus 1, okay, I don't know whether or not you need the dx. Now, I know I took points off on your test for not having the dx. I am sorry. But here's the deal. Some years, the AP readers, they're like, oh, yeah, they need the dx. we'll take off points. Some years, they're like, no, they don't need the DX. We won't take off points. So they basically told me that, oh. So if you don't have the DX, that's okay for me, but you need the DX. All right, so 1, 2, 3. Any questions? Go ahead and create your paper.
-2.
Did you only put the answer?
I got the answer. I got integral from b to a of fx. I don't write that.
Oh. Hey, did you cross this out and put f of x?
I just write
No. Oh, okay. Let me show y'all this. Let me show y'all this. Now, guys, these are time saver, but long try to save a little bit too much time. Okay? So, look. He just did the integral from a to b, the integral from a to b of f of x. So is that correct? No, because we don't know what a and b are. But, look here, f of x. If he had crossed out y up here and put f of x, we can do that.
Okay.
Then it would be right.
Okay.
Okay?
Yeah, good. So I -1.
Well, you didn't cross out y and put f of x. But,
Oh, okay.
so it would still be -2.
-1.
Okay. All right. So, all right, volume of the solid when R is revolved around the horizontal line, y equals 3. So, limits and constant. So limits and guys, we'll go over the different ways of writing this, right? But here are the limits. You're integrating from 1 to 10. The constant is pi, so you have pi. If you have pi there, and you have the limits, you get a point.
What is the limit?
Limits from 1 to 10.
Oh, I got that right.
You got from 1 to 10 in pi, you get the point. Yes.
And then you get the answer. I didn't get the answer. I got
We didn't put it in the calculator.
I got 90. Oh, it's just like it.
All right. So, would y'all like to see how the heck they got that integrand? All right, let me show you how they got that integrand. The integrand is the thingy inside the integral.
So 9 minus 3.
Oh, I got that right.
All right, so here's how I did it. Okay?
So it's like
Here's how I did it. Okay? So I said, okay, what's the big radius? Well, it's always going to be just this block. So what's the length? 3. And then what's the little radius? Well, it's the difference of 3 and this graph. So I just have to remember, and I was kind of a little bit distasteful because what should I have had here? A pi. But that works too. Okay? Minus 1. Minus 1. Guys, see this this picture? It does you a whole lot of good to draw a picture. You'll be surprised what you can do with a picture. Okay? Pictures are worth 1,000 words. That's right. So, go ahead and grade it. If you got the pi, 1 and the 10, that's a point. If you got the inside, that's a point. Or if you did it like my inside, that's a point. And if you got the answer, that's a point. Next. All right, limits and constant from 0 to 3. Okay? We're integrating. We're not integrating with respect to x. We're integrating with respect to y because we're revolving this way around a y-axis. So my radius, let me just show you your radius. So here's what, yeah, I got a bunch of scratching there.
Why, does it out?
So, I know this is a terrible picture, sorry. But look at this. This is sort of like a mound as this gets revolved. So the circles, here's my radius. Now, remember, guys, focus please. Remember, if your radius is a x value, you need to find out what x is. Okay, so your radius is an x value, right? So you need to find out what x is. I square both sides, I get that, boom. All right? Now, the x value is actually this entire length, right? So this part should be 10 minus, sorry, the x value is this length. All right? The x value is this length. So the radius is 10 minus that length. So basically, anytime your radius is flat, like this, you need to solve for x. And then use that for your integral. And this is just a disk method. So you're doing 10 minus your x, 10 minus f of y, boom. And I think I got my decimal off right there. It's kind of working fast though. All right, so go ahead and grade it. Any questions on the grading part?
-3.
-3? Oh no.
I have -7.
All right. We'll definitely use this to practice further. All right, this was a cool one. All right. Okay. All right, let's just focus on A. A was worth 1 point. All right, no, all you have to show is that the rate of increase is greater than 0.
So if I put R of 6 equals 4.438, is that right?
Did you say that the number of mosquitoes is increasing?
No, I just said that.
Well, you gotta, yes, but you need to answer the question.
You told me if I don't add. Oh my goodness.
Hold on. Oh, I'm sorry. Show. It says show, so all you have to do is show. Yeah.
So if I say that it's positive because I add less 6 into the equation.
Yes.
And it is greater than 0, therefore it's increasing the number of mosquitoes.
You need to, okay, Long, that's great, but you need to make sure that I know when I read it that you're plugging into the R equation.
I did that.
Okay.
I plugged it into the R equation.
Okay, that's correct then.
Okay. Does that work? Yeah, I gotta pull this one.
All right, so as long as you plug in 6 into R and it becomes a positive, that you've shown it, right?
Yep.
So B, at time t equals 6, is the number of mosquitoes increasing at an increasing rate or increasing at a decreasing rate? Okay? Give a reason for your answer.
I did say that because I named the answer.
Okay, now Long, all right, can you just say my answer was negative? No, you have to say what was negative. When you take the derivative of the velocity.
So if I wrote the answer,
Oh yeah, you just
look at it, it told me it might be because I did the work and
You did A of 6. A,
it's acceleration. It says something about it.
you can't say it's negative. Oh, when you take the derivative of velocity.
So would I take 1 point because I did that, but then I didn't do the other? I don't know. Because I put a time to 6 on the first. So is that right?
I think I know what you're saying.
So yeah.
Okay, any guys, number B, letter B, any like, this answer, I don't know.
how about look like this?
How about if it looks like this?
And
A of t equals 6, it equals
negative answer.
negative answer, it shows increasing at a decreasing rate.
Like C, the C, or you want to say?
Okay, You need to show, okay, this is fine, it's correct, but you should show, say A of 6 equals this.
Less than 0.
Or A of 6 just equals this. So bring that A of 6 and show me that I plug 6 into the A to get this. A of 6 equals that.
Okay, so you say that equal to A of 6 equal this one.
Yeah, that's fine. Now it's good. Okay.
So,
But I think it was fine to begin with. Alright, so any other confusing answers? No? Yes? Alright, moving on. You had to say that that this was less than 0, right? Or show that it's negative, since this is the answer for the acceleration. And there you go, you state the number of mosquitoes is increasing at a decreasing rate. Alright, here. Okay? Alright. C, according to the model, how many mosquitoes would be on the island at time t equals 31? What gives us the value? The integral from 0 to 31. But what do I have to add to it?
The initial thing. Yeah.
1,000. Okay? So there you go. Now, you had to show your integral. Okay? At some point, there has to be an integral. It doesn't even have to be the whole equation. You could have just put r of t. But if you put the whole equation, that's fine. So is there an integral from 0 to 31 of the rate? And is there an answer that is correct? Period. You didn't have to put 1,000 plus because you didn't have to. But be careful. Be careful. If you put your integral from 0 to 31 equals your answer, without the 1,000, is that right? No, think about it. This integral will give me a negative number. Negative 35. Okay? So if it gives me a negative answer and I put the real, if I add 1,000 to it without showing it on the left side, is that a balanced equation? No. So just check your equations, make sure they're balanced, okay? Especially when you're doing a bunch of stuff in the calculator.
Did we have to say to the nearest whole number? Or did it matter?
No, you just have to put the nearest whole number.
Okay. So I got my
All right, 2 points. Everybody got it? Last one. The nearest whole number. What is the maximum number of mosquitoes from 0 to 31? Show the analysis that leads to your conclusion. Okay? So, wow, this was a lot of points here. Okay. So, when we looked at the graph for this, didn't we? Okay. So, absolute maximum value. We looked at the graph of this, and it was greater than 0 for a certain point, less than 0. The rate was less than 0 for a certain point, and then greater than 0. Okay. So, the absolute maximum number of mosquitoes occurs at 1 or 2 points. Why could it be 2.5? Or, well, actually, this, if you convert this, hold on. 10.4? What is 2.5 pi L?
7.85.
And 31. Okay, so guys, look. So on the graph, the derivative, the rate was less than 0 greater than 0 from 0 to 7.85, and then less than 0 from 7.85 to 7.5 pi. It goes from positive to negative, right? So that makes it a candidate for the absolute maximum. Okay? It makes it a candidate for the absolute maximum because the derivative goes from positive to negative. Now you have to also consider the endpoint. Why isn't 0 a candidate for the absolute maximum? What happens right after 0? Yeah, the slope is increasing. The rate is increasing. So 0 can't be a maximum if it increases right after 0. So you plug both of those in, or you take the integral of both of those. All right? Didn't we already do the integral here? 964, right? Well, that definitely wouldn't be the answer. 964 is less than it started. So you do the integral from 1,000 from 0 to 2.5, you get 1039. Okay? So, all right, what are the points? Where are the points at? Let's look at this. Integral, you have to show your integral. If you didn't show your integral, no point. You have to show your answer. Didn't you have the right answer? No point. Okay? All right, you have to compute your interior critical points. What's a critical point? Where the derivative is equal to 0. All right? So, right there. So if you found out where it was equal to 0, 7.85, and whatever that is. Of course, that didn't matter because it was a relative minimum. And then complete your analysis, which basically means where does it go from positive to negative? Okay? I guess analysis in this case could be a sign chart. 7.85 to 7.5 pi. Could be a sign chart, right? It goes from positive to negative to positive. So if you got a sign chart, that's basically basic analysis right there. Any other questions on this? We got to get this whole thing done, so I'm going to kind of move faster, all right? Now this one we basically did in class. Yeah. So just kind of quickly go over it, okay? All right, so we did this one in class. Just going over it. Let's go over the points, though. Let's say you have a Riemann sum, and you're like, I can do this much. Is it really even worth it, or should I move on? Well, let's talk about what you get for the points. All right? Midpoint Riemann sum. We did see, this is wrong. Remember what I said?
Yeah.
This is incorrect because I'm not showing each individual area. I can't factor out the 10 and show my work. Okay? So, I have no idea what this means. Okay. All right. This should say show each area. Show each area. Not like show a graph, but show you that you're doing base times height, base times height, base times height. Okay? Now the answer was 229. That's worth a point. And you need to tell what the integral gives you. We did that, meaning with units. Okay? All right. So remember we talked about the acceleration, changing twice, justification of the answer. By the mean value theorem, MVT. Well, what we did, instead of using the mean value theorem, we just talked about changing the signs of the acceleration, or changing the signs of the acceleration / slope of the derivative, slope of VT. Okay, so guys, let's just finish this up real quick. All right. Any questions on this? This is pretty much what we had, but look at the points. Just 1 point for plugging in something. But remember, if you didn't write this, guess what? Wrong. You can't put like NDER equals negative 0.408, right? That is wrong.
Okay, so what if I put F prime of t? Yeah.
F prime of t?
Yeah.
Did you tell me what you were plugging in, like F prime of t at 23?
Yeah.
Yes.
Okay, that's fine.
Yes.
Okay.
That's what's
All right, so everybody got it? Okay. 3, 2, 1, 3. Everybody should have a perfect. Unless you didn't. Hey, also, if you forget this 1 over 40, guess what? Wrong, right? If you don't write your limits, wrong. Okay? So limits, integrand, answer. All right, let's move on. We just got a couple minutes. Now, we talked about this one yesterday. It was a doozy. All right. So yesterday, if you were here, you kind of got, and you know what? I kind of want to get to numbers 5 and 6. So let's just quickly kind of go over this. Quickly grade it. Quickly. So A, x coordinates of points of inflection, and points of inflections occur where the acceleration changes sign. Okay? So what's the acceleration? The derivative, Jose, slope of the velocity. So where does the slope change sign? Once, twice, right? X equals 1, x equals 3. And your reason, I think our reason was the slope changed. Slope changed signs. All right, so real quick. All right, this one, you know what? Don't even grade the second part of B, y'all. I think that was kind of a bunk question. It's just, we talked about it yesterday. We said that, in my professional opinion, you just don't take a look at the areas of the graph and say, oh, I think the maximum is this number. But basically, go ahead and grade the first part. The absolute minimum, because it decreases from -1 to 4, then increases from 4 to 5, absolute minimum. Now, if you just said that signs change from negative to positive, are you right? No. Because with absolute, what do you have to talk about? The whole domain. So this is, you have to indicate that f decreases, then increases on the whole domain. All right? And state that the absolute minimum is 4. Just grade this out of 2. So here's what I want you to grade. I want you to grade this one and this one. Just grade it out of 2. Okay? So indicates f decreases, then increases, and indicate your absolute minimum and x equals 4. All right. Next. Okay. This one was a tough one. Let me show you the work for this one. Raise your hand if you attempted 4C. Anybody? Okay. So if you have one person, all right. You attempted 4C. Great. So 4C looked like this. All right? Take a look at the work. G of x equals xf of x. Find the equation for the line tangent. Okay? So, you got to find the derivative for the slope. Product rule. First times second plus second times first. Derivative of the second times first. Derivative of the first times the second. Now you use the points above. Use the points above to plug in these values. Okay? They give you all the values. And then you find your slope, output of the derivative, and your point, your point can be indicated by plugging into this equation. See the equation they give you? They gave you the x of 2, plug that in. What do you get? Let's see. G of 2 times 2, f of 2. Well, what's f of 2? F of 2 is, where is it? This is f prime, right? So f of 2, where does it say? It said it up here, right here. Oh, you can't see it, sorry. F of 2 equals 6. Okay? So bam, 2 times 6 is 12. So the y value is 12. The x value is 2. Point slope form looks like this. Stop. Why should you stop? Because if you get y by itself here, if you add 12 to both sides and somehow mess up, guess what? It's wrong. No points. Okay? So that's why we use point slope form. You got 2 points for g prime of x. I don't know why. I guess they gave you a point for actually trying the derivative, and they gave you a point for plugging in 2. Did you get that right, Abby?
I got the y value.
You got the y value right?
I got 12.
You got 12? All right, cool. All right, so cool. Golly, running on time. Question 5. Question 5 we should have rocked the house on, because we just did differential equations. All right? So, oh my gosh, look at this. You could practically pass the AP exam just by doing this question. This is worth 6 points right here.
I got 1. What?
Okay? All right, so take a look at A.
I got 2. Oh, I got
0 slopes. They give you a point for the 0 slopes. And they give you a point for these positive slopes. And a point for these, or just 1 point for where it's positive and where it's negative, okay?
Yay. I got 2 points.
So if these are all flat, you get a point. If these are negative, you get a point. And if these are positive, you get a point. Actually,
Positive like negative like this.
yeah, positive like this,
You get half a point.
negative like this.
So this line is like 0.
0.
And why the y is like 0?
Because that's, what's x right here? X is 0, x is 0, x is 0, x is 0. When you plug in 0, when you plug in 0 into this x, look,
The slope is like
slope becomes 0. All right. So, y'all got that? Now, I hope y'all tried AB. Okay? The slopes are negative. Guys, you just gotta, there's always a question on the AP exam like this. The slopes are negative. Let me get on the side. When y does not equal, well, actually, when y is less than 2, right? And x is not 0. So x is not 0, y is less than 2. You just got 1 point for that.
see, look at
C is worth a lot, huh?
Find the solution y for fx to give a different equation where initial
Okay. So, did you separate the variables? Did you get this? Give yourself a point.
No. What?
Did you separate the variables? Did you get this before you integrated?
Oh, yes, separate.
Alright? Alright, did you do your antiderivatives correctly? Did you get this? Give yourself a point. Okay? Did you put C? Oh, you get 2 points. 2 points for taking the derivatives, or the integral. Give yourself 2 points. My bad.
Why don't we just skip over?
Did you put C? Give yourself another point for putting C. Did you plug in your initial condition? As long as you plugged your initial condition in, give yourself a point.
Wait, what would happen if, I'm gonna say 90%. Like, if you just put C, like, on the question, would they give you a point?
Here's the thing, guys. If you kind of like separate the variables by playing tic-tac-toe, just moving them around, not doing any real math, and then you whap an integral on it and just put a plus C, what you've done is you've made the problem easier, right? Because if you don't do it the way they want you to do it, usually you end up with an easier problem, and they don't award you any points for an easier problem. They want you to do their problem.
Wow.
So if you mess up here, but do all this correctly, as long as you didn't make it an easier problem, they'll give you the points. Because what some people will do is they'll be like, I can't do that. I'm going to make it really easy so I can take the integral.
How do you make that really easy?
Well, if you just like put y minus 2 dy instead of 1 over y minus 2.
Well, that doesn't make sense because you just solve it.
Exactly. Some people will do that because they forget the natural log tool.
But that's just wrong. That's just wrong.
That is wrong.
That be the wrong answer. I thought it meant like.
Okay.
Yeah, like running.
Sorry guys, we gotta move on. Okay? So initial condition, if you plugged in that point, you get a point. If you got y by itself, you get a point. And 0 out of 1 if y is not exponential. I don't understand. It ought to be exponential. You gotta drop an e on both sides. Okay? And you get no points. Or you get half the points if you don't put C. And you get no points if you don't separate the variables.
So you get half of the points if you put C?
If you don't put C, they cut off half of your points. Now here's how I did it. Let me show you how I did it. Right here. Okay? Separate the variables, drop an E, plug in C. C is the natural log of 2. Any of y'all get this and not that mumbo jumbo they got? They got something different, but this is mathematically sound. This is the way I've been teaching you to do it. Now, what could you do with the E and the natural log of 2?
Cancel them out.
Cancel them out if you want to. But you don't have to. See, this is the way I would teach you to do it, right?
Yeah.
Because on the key, they took E here and E here, and then canceled out the natural log of the E. See, I'm not even worried about that. Just leave it like this. See this? See this right here? When you're done, you gotta stop. Plug in 0, -2, find the C. Find the C, and then I add 2 and I'm done. Stop. Don't do any more. Alright guys, last question. That was 6 points. Alright. Now this was R number 6, okay? So as long as you can plug this in your calculator, it was question number 3, so it's calculator active. R number 6 right here. So you should have been able to do this whole thing with your calculator, okay? So question A, find the acceleration. You need to state the calculus. It's the derivative of the velocity, right? Boom. All you got to do is put the answer because it's a calculator question.
Oh, I did that before and I erased it because I thought it was wrong.
All right. Is the speed increasing? Right? Is the speed of the particle increasing or decreasing? Speed is increasing since, wait, less than 0. Did y'all get acceleration is negative? Yeah, the acceleration is, it should be speed is decreasing. That's wrong. Oh, I'm sorry. No, I'm wrong.
Shame on you.
You know what? Yep, I'm totally wrong. I am totally off base. Totally out of another world. Why is the speed increasing?
Because the velocity is increasing.
No. What's the velocity doing?
Negative.
Negative. And if the acceleration is also negative, that means it's the speed is getting more negative. And speed, do you care about negative or positive?
Oh, I see.
Okay, so if y'all taken physics before, you know what I'm talking about.
Got it.
If you got a negative velocity and a negative acceleration, your speed is increasing. It's just like you're hitting the gas, but in reverse. So your speed is actually increasing. That's my fault. If you missed that point, you can just chalk it up to Coach B. All right, last one. Or last two, sorry. Find when the particle reaches its highest point. Okay? Well, okay, you got to find out when it equals 0. Okay? So when it equals 0, that would be x equals 1, and you can look at the graph. Did we look at this one? Did we look at the graph for this one?
Yes. Yes.
Okay. Yeah, 0.443.
It was like this.
It's the only critical value. Then we said the velocity was greater than 0 and then less than 0. So greater than 0, less than 0. That means it's an absolute maximum. But you have to state the whole domain. Okay. Raise your hand if you're going to be able to be here tomorrow. Okay? Those of y'all that will be here, you will receive some sort of extra credit grade. I don't know. Okay? That's all I can. And we're going to group up, split up, break out at 9 to 11. 9 to 11 tomorrow. And we'll meet here. 9 o'clock.
Which, like,
Where's
you
here?
go on the fall.
Just get here at 9.
Like this.
Where is here?
This classroom. We would go to the field house, but
Yeah, do we come after the front door or the back door?
Yeah.
come through the back door. Set the alarm off. You did? That's okay. All right. Please write the number missed at the top. Okay? Write the number missed at the top. And tomorrow, while y'all are working, I guess, who's not going to be here tomorrow? Just let me know if you're not going to be here tomorrow.
Depending on Kevin's soccer game. I don't know what time it is.
Okay, if you're not going to be here tomorrow, give me your AP stuff so I can go ahead and record it. And while y'all are working tomorrow, I'll record these grades. And guys, don't worry about whether it's perfect or not. Okay? So I'll get these tomorrow and I'll record them. I'll see what we can do with them. I might just make it an effort grade.
Come to the attendance office to check out. Family
Oh, next Tuesday, don't be absent. We have our student learning objective test.
Olivia Madrigal, Tyler Moon, Helen D. to Student Services. Olivia Madrigal, Tyler Moon, Helen D. to Student Services.